Hello, my name is Rob Krieger. I am the chair of the math department at Concordia University St. Paul, and I've been working on putting together this course for you. And I thought creating a video to help students understand what we want them to know from Module 15 would be helpful. So this is example 12.6 from OpenStax. I've adjusted the data a little bit from that example to give you a fresh perspective. And the problem originally states this: a random sample of 11 statistics students produced the data where X is the third exam score out of 80 and Y is the final exam score out of 200. So we couldn't do a typical t-test for these because they're different types of data, right? Coming from different types of data sets out of 80 points and out of 200 points. And so the way we analyze this is through this process of regression analysis. So to begin, you'll notice that this is the Excel spreadsheet that you've seen from some of the other examples that we set up for you in this class. And you'll need to be able to fill out some similar spreadsheets for your homework assignment for the last module here. And so I want to show you how to do this. So first of all, of course, we want to look at our formula sheet. Notice that from Module 15, we want to know how to find sample means. X bar is the variable for a sample where mu was the variable for populations. And so we've got X bar is the average of the X's over N, and Y bar is the average of the Y's over N. And then we've got these funny looking sums, the difference of xi and x bar times the difference of yi minus y bar. And so that gives us these different types of equations that we need to use to be able to find r and r squared. The r is the correlation coefficient, and r squared is the coefficient of determination. And we will also use them to help us find the equation of the regression line. And so those are things, hopefully you've watched the video, maybe practiced some problems in My Open Math, and I want to show you how to use the spreadsheet to help you find some of those answers. So first of all, we need to be able to find those averages, x bar and y bar. There's a couple different ways of doing it. First of all, we need to sum those values. Now, some of you know how to use Excel proficiently. Some of you have never seen Excel before, so I'll go through some basics here. First of all, anytime we do an equation, we type an equal sign, and I want to take the sum. Excel has a built-in capability of finding the sum, and so I double-click that, and it allows me to add a bunch of numbers, right? Sum of a bunch of numbers. I can highlight the numbers while I'm in there, and it goes from B4 to B14. And so you could have also typed B4 colon B14 for those values. And so I close the parenthesis and I hit enter, and notice that it takes the sum of those values from B4 to B14. You can always check the equation up here in the equation bar. I want to do the same for the y's, and so there's a couple different ways. Again, we can use some power of Excel. Notice that the cursor changes as I float to this bottom right-hand corner. So I can drag it across, and it's going to copy the same equation, however, for the new column. So notice this column up here says B4 to B14. When I did the drag, it's going to be C4 to C14. And so that's a benefit of Excel. Now, there's a couple different ways of finding the average. Notice how I clicked on that. That's the image. So you want to be careful not to delete those images that I've got in there for you. So I'm going to click this cell, and I want to find the average. I can either use the built-in formula. So average, if you start typing average, you'll see a bunch of different kinds of averages. I'll double click this first one, and I can find the average of that column. And so again, B4 to B14. And so the average is 69. The other way we could have done it, and I'll do that over here in this cell, is we can use that formula from our formula sheet, and notice it's the sums divided by n, the number of data values. And so we can do, first of all, oh, there I clicked the image again. So in the cell, the equals, and the sum is up here, so I can click this cell. C15 was the sum, and I can divide by the number of values that we have, and notice that we had 11 values in our data set, and that will find the average. Similarly, right, so let me just show you, we could have clicked this cell, change the cursor to the bottom right corner, slide over, and we get the same answer either way. Okay, so now notice in all of these equations, we're going to use that y bar and the x bar. And so you can do two things. You can type in the values, so 69 and 159 point, we could use 4, 5, two decimal places are adequate, or you can name those cells. So I want to show you this because I think this is a powerful thing in Excel. And so when you click, you left click it to make sure you're in the cell, and then you right click and notice that one of the things I can do, make sure I'm in there, is I can define the name. And so I'm going to define the name as X bar. And so I hit OK. And now if you notice right here, I've got X bar as the name of that value. So if I go over here and I right click, I'm going to define the name for that one, and this one I will call Y bar. And so if I click back and forth, notice that this B16 is X bar up here, and I click here, the C16 is the Y bar. Now I'm going to be able to use those in my equations. So if I hit equals, I want to take the X value, so I'll click on the X value, and then I can do minus, and I can either click on this 69, which is the X bar, notice it puts it in, or I could have started typing it. I'll show you that for the Y bar column. So I hit enter, and notice that it took 65 minus 69 appropriately. And remember, we want to use the copying capability. So you click it, go over to change the cursor, and I drag down, and it will do all of the subtractions. Let me just click this cell. Notice up here, it's the B12 minus the X bar. So it remembered the X bar all the way down. Okay, so now we want to square that. So you hit equals. We're going to take this value and we'll square it. And so you use the shift over the 6 is the caret key, and then the 2 for squaring it. And notice negative 4 squared is positive 16, negative 4 times negative 4. And so we do the same thing, copy it all the way down, and those are our values. So now let's do the y bar. And so we'll do equals, we click the y, and then the subtract. Now this time I'm going to start typing y bar, and notice it gives me the choice. So I click it, hit enter, and so 175 minus the 159.45 gives us the 15.54, so that's correct. Again, we'll copy from the bottom right corner, and we get all of those values. And now we want to square those, so we equal, we click it, caret 2, and of course all of those become positive because we're squaring them, and we copy it all the way down to the bottom. Now we take a look at this final column. Notice it is the x minus x bar times y minus y bar that we need in the s sub xy from our formula sheet, right? S sub xy was the sum of the xi minus x bar, yi minus y bars. And so we hit our equal sign and we click this cell right here, and then we multiply. So shift over the 8 is the multiply, and we click this one. So it's D4 times F4, and we hit enter. And so now we drag all the way down. Notice some of those are negative because we had a negative 4 times 15. So some of those are going to be positive and some of those are going to be negative. All right. Again, going back to our formula sheet, notice each of those are sums. And so we need to take the sums for those three values, again, to be able to find our correlation coefficient and our coefficient of determination. So going back to Excel here, let's take the sum. So it's equals the sum, and we'll add all of those up, being careful to only choose the right values. So that's 110, will equal this one, the sum of all of these. And because we can go right next to it and do another sum, I'll use our little trick, and that gives us the sum of all of those. Sum from age 4 to age 14. With all of those decimals, it actually just turned out to be an integer value, which is interesting.